Something with a mass of 10 million suns is currently tearing through a galaxy at over 1,000 kilometers every single second, moving so fast that nothing in the universe can catch it, and so fast that it has permanently escaped the gravitational grip of its own home galaxy forever. For 50 years, scientists theorized that objects like this should exist somewhere out there in the cosmos. They had never actually seen one. Now, using the James Webb Space Telescope, astronomers have finally confirmed it, and the story of how they found it, tracked it, and proved what it really is might be one of the strangest detective stories in modern astrophysics. To understand why this discovery matters so much, you first need to understand what a supermassive black hole actually is and why the idea of one going rogue sounded almost impossible for decades. At the center of nearly every large galaxy in the universe, including our own Milky Way, sits an enormous black hole, often millions or even billions of times more massive than our Sun. These objects don't wander. They sit anchored at the gravitational heart of their galaxies, holding entire spiral arms and stars, systems in orbit around them for billions of years. The idea that one of these cosmic anchors could somehow break free and go rocketing off into intergalactic space on its own sounds like something out of science fiction. But theorists have long predicted that under exactly the right, exceedingly rare circumstances, it should be possible. The story of this particular discovery actually begins back in 2023, years before Webb ever entered the picture. A team led by Yale astronomer Peter van Dokkum was sifting through archival images captured by the Hubble Space Telescope when they noticed something strange. A thin, oddly straight line of light stretching across a distant galaxy. At first glance, it looked almost like a scratch or an artifact on the image, the kind of visual glitch astronomers see all the time and usually dismiss without a second thought. But this line didn't behave like a typical imaging error. It was long, remarkably straight, and appeared to be a genuine physical structure stretching an almost unbelievable 200,000 light-years across space, roughly twice the entire diameter of the Milky Way galaxy itself. The Hubble image itself captured this galaxy as it appeared roughly halfway back through the entire history of the universe, meaning the light researchers were studying had been traveling toward Earth for billions of years before anyone ever noticed the strange streak buried within it. Follow-up observations using the Keck Observatory in Hawaii helped the team piece together what they were actually looking at. That strange streak wasn't a scratch or a glitch at all. It was a trail, a wake of freshly formed young stars, left behind by something massive moving at incredible speed through the gas and dust of its host galaxy. Based on those early observations, the team estimated that whatever had carved this trail had a mass equivalent to roughly 20 million suns. It was, they believed, a strong candidate for exactly the kind of runaway supermassive black hole theorists had predicted for half a century. But a candidate wasn't the same thing as confirmation. There was no way, using the instruments available at the time, to prove beyond doubt that a black hole actually sat at the tip of that glowing trail, quietly speeding away into the darkness. As one researcher, involved in the original 2023 work, later put it, all they really had back then was a streak that was difficult to explain in any other way, but proof itself remained frustratingly out of reach. If you're finding this as fascinating as I did digging into it, go ahead and hit that like button. It genuinely helps this channel keep growing. That's where the James Webb Space Telescope came in. Van Dokkum's team returned to the same target, a distant pair of merging galaxies nicknamed the Cosmic Owl, located roughly 8.8 billion light-years from Earth, and turned Webb's far more sensitive infrared instruments directly toward the tip of that strange stellar wake. What they found there settled the debate once and for all. At the very head of the trail, Webb detected the unmistakable signature of a black hole, actively pushing through surrounding gas, compressing and heating the material directly in front of it as it plowed forward at extraordinary speed. By measuring exactly how that gas was being displaced and disturbed, astronomers were able to calculate the black hole's velocity directly from the Webb data itself, arriving at a speed of approximately 1,000 kilometers per second, or about 2.2 million miles per hour. To put that in perspective, that's roughly 3,000 times faster than the speed of sound here on Earth at sea level, a velocity so extreme it made this black hole not just the first confirmed runaway supermassive black hole in history, but one of the single fastest moving objects ever detected anywhere in the observable universe. Van Dokkum later explained that the velocity of the displaced gas is directly tied to the velocity of the black hole itself, which is precisely how the team was able to pin down its speed using nothing but the Webb data alone, since the black hole itself remains completely invisible, detectable only through the destruction and disturbance it leaves behind in its path. Even more remarkable, Webb revealed that this fleeing black hole isn't traveling alone or quietly. As it barrels forward through space, it's generating a colossal shockwave, Essentially, a galaxy-sized sonic boom made of compressed gas and radiation, pushing outward ahead of the black hole like the wake in front of a speeding boat, except on a scale that dwarfs entire star systems. And trailing behind it stretches that same 200,000 light-year tail first spotted back in 2023, a long ribbon of gas where the black hole's passage has triggered the birth of brand new stars, essentially seeding fresh stellar nurseries in its wake as it flees. Peter van Dokkum, reflecting on the discovery, described the sheer scale of what would be required to eject something this massive from its galaxy as almost impossible to fully comprehend, remarking that the forces necessary to dislodge an object of this size from its home were simply enormous. He also admitted that virtually every aspect of this research had managed to surprise him personally, adding that he never expected a project that began with a strange, unexplained smudge in an old archival image to eventually deliver definitive proof of a decades-old theoretical prediction. So how exactly does a black hole with the mass of 10 million suns get kicked out of its own galaxy in the first place? Astronomers have proposed two leading explanations, and both begin the same way, with a galactic collision. When two galaxies merge, and this happens constantly across cosmic history, each one typically brings its own central supermassive black hole to the newly forming combined galaxy. As the merger settles, these two black holes are drawn together toward the gravitational center of the new galaxy, spiraling closer and closer over time. In the first proposed scenario, the two black holes actually merge completely. If that merger happens asymmetrically, if one black hole is spinning in a slightly different orientation than the other, the resulting gravitational waves released during the collision can carry away momentum in a lopsided way, giving the newly merged black hole an enormous recoil kick, flinging it away from the galactic center entirely, much like the recoil of a fired weapon. In the second proposed scenario, a third black hole gets involved before any merger can complete. If a third supermassive black hole happens to be present, perhaps from an earlier galactic collision, a complex three-body gravitational interaction can occur, where the physics of orbital mechanics ends up slinging one of the black holes outward at tremendous speed, similar in principle to how spacecraft use gravitational slingshot maneuvers around planets to gain velocity, just on an almost incomprehensibly larger scale. Distinguishing between these two scenarios matters a great deal to astronomers, because each one leaves behind slightly different physical clues, and figuring out which mechanism actually launched this particular black hole could help researchers understand just how often galaxies throughout the universe have experienced this kind of dramatic, violent ejection over cosmic history. What makes this Webb confirmation so significant isn't only that it validated a 50-year-old theoretical prediction, though that alone would be a major achievement. It's that this discovery appears to be just the beginning. In the same general period, astronomers studying other galaxies began noticing similar telltale streaks using Webb's powerful infrared vision. One particularly striking example turned up in a galaxy called NGC 327, where researchers identified another long, straight contrail cutting directly across the galactic disk, this one attributed to a somewhat smaller black hole estimated at roughly 2 million solar masses, traveling at around 300 kilometers per second. Still an extraordinary speed, even if less dramatic than the record-breaking cosmic owl object. Multiple independent research teams published papers throughout 2025 describing these strange, unusually straight stellar streaks as compelling evidence that runaway black holes might be far more common throughout the universe than anyone previously suspected, hiding in plain sight within Hubble and Webb archival images, simply waiting for someone to notice the telltale trail they leave behind. Before this wave of research, these bright straight lines cutting across galaxy images had occasionally been noted by astronomers, but were typically dismissed as imaging artifacts, cosmic ray hits, or satellite trails accidentally captured during long exposures, meaning it's entirely possible that genuine runaway black holes have been sitting quietly in plain sight within astronomical archives for years, misidentified as nothing more than technical noise. This raises a genuinely thrilling possibility for the future of astronomy. If these bright, straight streaks of young stars really are the signature calling card of a fleeing, supermassive black hole, then astronomers suddenly have a practical, repeatable method for hunting down more of them, essentially searching through decades of accumulated telescope images for exactly this kind of anomaly. Peter van Dokkum himself noted that the obvious next step for his team and others in the field is now to search for additional examples, using this confirmed discovery as a template for what to look for. Given how many galaxy images already exist in astronomical archives, some scientists suspect that dozens, or possibly even hundreds, of similar runaway black holes might already be sitting undiscovered in existing data, simply waiting to be recognized for what they truly are. Some researchers have even suggested that future dedicated searches, specifically designed to scan wide fields of galaxies for these telltale straight streaks, could turn what is currently a rare and celebrated discovery into a fairly routine category of astronomical object within just a few years, fundamentally changing how common scientists believe these violent galactic ejections really are. There's something almost poetic about the fact that this discovery required two different space telescopes working together across a gap of more than 2 years to fully confirm. Hubble spotted the mystery first, capturing a fragment of light too strange and too straight to be dismissed as noise. But it took Webb's far more advanced infrared vision, sensitive enough to detect the subtle signature of gas, being violently compressed by an invisible speeding object, to finally prove that a genuine black hole sat at the heart of that ancient anomaly. It's a reminder that some of the universe's most profound discoveries aren't made in a single triumphant moment, but slowly, patiently, across years of returning to the same strange piece of data with better tools, and asking the same nagging question again and again until an answer finally emerges. Consider, for a moment, the sheer violence embedded in this story. A black hole carrying the mass of 10 million suns was essentially fired out of its own galaxy like a bullet, the aftermath of two galaxies colliding somewhere in the deep, ancient past of the universe, and now it races onward through intergalactic space, permanently severed from any galaxy at all, dragging a 200,000 light-year trail of newly born stars behind it like the smoke trail of a rocket. It will likely never slow down. It will likely never find another galaxy to call home. It will simply continue on, alone, forever, an isolated black hole drifting through the emptiness between galaxies for the remainder of cosmic time, a permanent physical monument to one of the most violent events the universe is capable of producing. Somewhere out there, countless other galaxies may be quietly harboring their own version of this same event, an invisible black hole silently fleeing the wreckage of an ancient collision, waiting only for the right telescope, pointed at exactly the right patch of sky, to finally notice the faint, telltale trail it has left behind. For decades, this entire scenario existed only on chalkboards and in theoretical physics papers, a mathematically plausible outcome of galaxy mergers that nobody had ever actually witnessed. Now, thanks to the combined efforts of two of humanity's greatest telescopes and a research team patient enough to chase a strange streak of light across more than 2 years of observations, runaway supermassive black holes have officially left the realm of theory and entered the realm of confirmed observed reality. And if the early evidence from galaxies like NGC 3627 is any indication, this cosmic owl discovery may turn out to be just the very first of many similar fugitives astronomers are about to find hiding throughout the universe. It stands as a genuinely rare kind of scientific milestone, the moment a phenomenon predicted purely through mathematics finally reveals itself in the real sky, captured in light that traveled across billions of years just to reach a telescope built specifically to catch it. If stories about the universe's most violent and unexpected phenomena keep you coming back, make sure you're subscribed, because there are plenty more cosmic mysteries like this one still waiting to be uncovered.